Based on that, I will explain the simple expanded set of abilities of particular MCDA methods. And finally, I will try to explain the methodology and expert system foundation supporting MCDA method selection in sustainability domain. Generally, as we see, we are observing the rapid development of new operational research branches. As you all know, the recent challenges of operational research are using the new generalization of, for example, fuzzy set theory. Based on the new extension of fuzzy set theory, we can observe that one method has 10, 15 new extension, taking into account new form of modeling of hesitation and imprecision in data, in preferences, and so on, so on, so on. However, from a practical point of view, when we see the sustainable, we wonder about sustainable decision making. When we think about sustainability, we have taken into account the same question we are basis for MCDA methodology. First, existence of multi-criteria. The second, we have to take into account the sum of criteria are conflicting each other. Third, the decision-making situation, the object under evaluation can be complex, and the nature of the evaluation process can be subjective or objective. It depends on the goal of decision situation or on the research. As we know, we can use objective weight or subjective weights in the CDA and so on and so on. Additionally, when we think about complex decision situation or about sustainability, financial aspect cannot be omitted and must be taken into account during the evaluation process. As we know, years ago, operational research ignored the human elements, and emotional factors were not taken into account. Right now, they are involved in the research also. As we know, due to ability to take into account the conflicting criteria, multi-criteria nature, and so on, so on, so on, MCDA and CDM decision analysis are widely used and rapidly developing last years. It's of course related, as it's wrote, with the changing paradigm when we start to optimize one goal in the place when we start to look for rational decision problem solving. Rational means that the results should fulfill all criteria defined by decision maker. The level of criteria must be not less than given values by decision maker, and different different methods exist. They belonging to the different branches, different school, and so on. As we know, MCDA is only part of operational research, but they give us a very powerful and useful tools to solve many practical problems, especially in sustainability domain. When we give a step back, and the system analysis should give us some basic assumptions. For example, the decision domain can be defined as a triangle positioned between rational and irrational decision, irrational, not rational, and of course rational, not rational. Yeah. in this domain, we have to find the solution, what is most satisfactory for decision maker. That's a formal. From mathematical point of view, you know it well. It's illustrated on two or three functions. We can obtain something what is called Pareto solution, but which of them is the best? It's difficult to prove it in mathematical term, A or B. Yeah, it should be properly chosen by decision maker. And when we keep it in mind, we know that it's a foundation for multi-criteria decision analysis to find the solution, the most satisfactory, the most satisfying the decision maker. That was a background, formal background. From practical side, sustainability and practical usage of MCDA in multi-criteria decision analysis method is very broad. They are applied in many practical problems, technical, economical, and especially management problems. Forecasting, analysis, financial, banking, risk management, production, logistics, well-known academic are very often used problem of supplier selection, green supplier selection, sustainable supplier selection. It's a core of MCDA. As they are used, as I said, MCDA are used in many fields and discipline. The sustainability from practical side, when we analyze the market, the direction, and the recent developments in the term of the world strategy, the European strategy is to make the world more sustainable. What does it mean sustainable? Sustainability covers different aspects of our human life. Sustainability take into account environmental factors, sustainability take into account human factor, economical factor, and we have to find that solution what is most acceptable in the term of all conflicting criteria. Different goals of sustainability are not with accordance with of course, economic goals. It can be easily shown, for example, in modern transport or modern production. If we are planning to produce something cheaper, it will be not influencing good for environment. Yeah, the emission CO2 and so on. Special goals are defined here, and as I said, society, environment, economy, and four-factor people. People involved in modern management, and it's broadly discussed. So new branches of management also has been developed. Right now we are calling sustainability the branch sustainable management. Concepts from sustainability are introduced in modern management as one of main goals. It can be omitted, but when we take into account the conflicting criteria, and when we wonder about sustainability domain, we will see that the MCDA methods are very powerful tool to solve the sustainable based problem. As I said, supplier selection, vendor selection, site location, strategy, operational decision, all of them will consist of many alternatives, and we will take into account sustainability-based conflicting criteria. That's why the MCDA methods are widely used. from research perspective, some exemplary papers we will see here. We will see the old papers which allows us prove us that MCDA are a powerful tool. On the one hand, the research should us give the contribution in the term of methodology. On the other hand, the modern research should give us some domain practical contribution for managerial or let's say managerial implication. The most mainstream research oriented in sustainability and in MCDA is, of course, to connect these two contributions using, for example, new development of particular MCDA methods. We use new generalization of selected fuzzy sets, and we apply it to new or old MCDA method. We'll prove some additional properties which better reflect the decision-making situation. Case study provide us usefulness for our approach to particular sustainable make decision situation and decision-making process. That's classical. I'd like to focus in my presentation on the other aspect. As you are, as I said, mathematics formal oriented. That's easy for you to expand new old or build new MCDA method. But what is most important is to prove the usefulness in practical domain. That's one. And the second, the aspect which is often very problematic. The authors use MCDA method without explanation, without justification of selection. When we see the MCDA branch, we can observe the development of MCDA methods, and we can easily find hundreds of MCDA methods. The set of MCDA methods cover, let's say, 50 or 100 basic methods and hundreds of extensions. But which of the method is proper for particular sustainable decision-making situation, and what's the proof that method is proper? We have to keep in mind that different MCDA methods can yield different results, and aggregation procedure differs. So, yes, justification for the method selection for particular paper, for particular research is a must. So we'll try to focus on the domain. When we take into account the basic, the foundation of MCDA, the papers like Gittoni, the papers the father of MCDA school, Bernard Roy, we'll see that the decision-making process can be divided in 5 steps: structuring, modeling preferences, aggregation, exploitation, recommendation. In practical terms, we know as we are analyzed, we have to build our decision-making model. During the structuring process, we have to obtain the set of alternatives and the set of criteria. Additional preference modeling, next step, calls that we have to properly reflect the decision-making preferences and obtain the preference in the form, for example, weights in European school-based method thresholds, and so on, so on. We can find useful the pairwise comparison, for example, AHP method basement, and so on, so on. Preference modeling, that's the stage when we have the preference modeled and the model structured, the aggregation procedure should be used. Long story short, or easy term, the multi-criteria method must be selected and properly used to properly explode and obtain proper results. That's in easy words. What we have to keep in mind that selection of MCDA method must be realized carefully, properly reflecting the decision-making factors and all decision situation. When we take a look on MCDA methods from basic taxonomical view horizon, we can select two basic subsets of MCDA methods. This method belongs to American school, and the second branch, they are European-based school. American school are well known as an easy to apply methods like HP, Topsis method, and so on. European-based school covers the school fulfilling the Slovinsky or Roy assumptions. Mainly consist the methods which are using the outranking relation. Of course, incomparability is also allowed in European school. The main difference between these two schools is that first school gives us quantitative results. Every alternative is evaluated in the term of quantitative. In the second school, European school, the final results very often produce as partial pre-order or final order, but mostly we will not obtain the quantitative results. It makes the lecture-based methods we are talking about only partially useful for sustainability, for example, measurement. We have to keep in mind that they are powerful, but not always fits to the problem and do not allow us to proper problem solving. It was told by me a while ago, American school used two basic relations, difference and preference, of course, between alternatives, while European-based school extend the paradigm of preference and difference using two additional relations. It can be easily said that one alternative is outranked by other when it's at least not worse than it. No, that's easy words. We have two alternatives equal. We have weak preference, strict preference, and incomparability. It built us outranking relation. Of course, these two schools can be mixed. We have also rule-based MCDA methods, and these are the present developments. When we take into account another point of view, the data characteristic can be a criterion of dividing the MCDA methods. The nature of data, scale are here can be used. Of course, I already talked about fuzzy set theory, and we know about weights of criteria. When we take into account this basic criteria of building the taxonomy, methods can be divided using criterion like relation used, what is important, type of aggregation, it was said, preferential information, we know it can be deterministic on or fuzzy binary relation. What is important, the linear compensation effect. I will say a few words about that. from a mathematical point of view, well, that's easy to understand, but we have to keep in mind that the sustainability. There are some situations where the compensation effect should be allowed. For example, when we evaluate the overall production of renewable energy sources for region, for country, it doesn't matter if the country used the solars or wind farm. The most important is overall performance and the producer's amount and so on. On the other hand, when we are looking for some sustainable solution, when sustainability factor is only one among others, the compensation effect, linear compensation effect, should be reduced, or the exist should be used. We know it well. So, from that point of view, it's worth to investigate the particular decision problem. The basic taxonomy using that 4 criteria. Now, as you see, there is many methods from here. European school, some easy methods from American school. That basic taxonomy covering the basic characteristic of MCDA selected, MCDA method, of course, selected. Yeah. We try to build our taxonomy to better reflect the abilities of methods to properly fit the methods to the particular decision situation. When we are talking about the MCDA methods selection, we should wonder about some additional factor. The complex multi-level character of decision problem. Forum dialogue with decision makers, how to model the implicit preference and assessment, missing situation assessment. All these factors cause that when we build our taxonomy, we should wonder how to reflect it and how to build the rules to properly select the MCDA method to the when we see to the literature examples, we will see hundreds of methods used for the problem, but which of them is proper? It depends on the situation. In my humble opinion, it depends on situation, number of criteria, the aim of the problem structuring, and so on, so on, so on. And only careful analysis of decision-making factors and whole the context cause that the particular MCDA method is properly selected to the problem. From formal point of view, when we analyze the literature from the subject of investigation, we will find that researchers says that decision makers are often unable to fully justify the choice of the method selection. When we ask the authors of manuscript to justify the method, that's very difficult for them to say that this method better fits for the problem than other. As we know in practice, the selection of MCDA methods is rather omitted, and we use that method which are familiar on, which we have software tools developed, and so on, so on. Yeah? But from formal point of view, from the research science principles, we have to select MCDA method properly to give the objective results of decision support. Of course, in mathematical terms, it's very difficult to answer the question which method is better and proper for given kind of problem. The selection of the method is silent. We have to keep in mind that the various methods, MCDA methods, can produce the different results, different rankings for the same problem used. It's caused by the calculation procedure. We know that the particular techniques use the weights, for example, in different form in the calculation. The scaling of the best solution differs in algorithms. Many algorithms scale to the objective. Of course, it affects the final results. Some results, as we know, introduce the additional parameters. For example, when we take into account a lecture-based family method, additional parameter consists of three thresholds. On the one hand, we have the hesitation and the decision maker and the preferences properly modeled, but on the other hand, the final result can differ from classical, for example, AP method. So when analyzing the literature, we can find some attempts to give the guidelines, to give the more or less formal frameworks to method, proper method selection for particular decision situation. However, when we look for the algorithms, how to select MCDA methods, it's very difficult to find the clear and ambitious guidelines. Of course, we can find some strict formal works when we have some MCDA method benchmarked, but authors, what is obvious, benchmark only selected subset of methods in the term of selected dataset range. The wider use of whole MCDA method set is still questionable. When we carefully analyze the formal approaches to the MCDA method selection, we can find some works where the decision tree are built for the family consisting of 5 or 6 MCDA methods. The main disadvantages of these approaches is that we have the final results of classifying oscillating the border or acceptability, and as I said, the domain range and the set of methods is also questionable. What can be proposed as a formal guideline, as a approach for proper method selection? We realized our research in a few steps. The final step will be, in my humble opinion, the easiest to understand, but we try to carefully analyze the basic literature, and they are very useful. Gitany-based articles give us starting guidelines how to properly select MCDA methods. In these articles, the new term is introduced. It's called the context of decision situation. Based on this article and the word context, we built the family of criterion supporting the selection the MCDA method for particular decision situation. Category, domain, existence of concrete criteria, description, cardinality of attributes, decision variant, degree of knowledge of decision situation from our decision maker, purpose of decision making, and of course we specify the range of attributes, and based on that we analyze some sustainability-based literature, and we obtain the values of the attributes. It takes a lot of time because we have to carefully analyze every particular article, word by word, in our research team, and finally, after over 100 papers analyzed, based on the data obtained, we build the easy decision tree, how to select particular decision, AHP, ANP, elector-free, fuzzy AHP, fuzzy ANP, Prometi, fuzzy Topsys, and so on, so on. These are abbreviations, and we will see how to select the methods. But in the formal term, for you, for mathematics, for all of us scientists, the TPR rate, as you see, is the same situation like in a real research. It's in the border of acceptance. This research did not give us clear guidelines which method where should be used, which attributes cause the selection of particular MCDA methods. It's also confirmed by decision matrix when you see a lot of examples which are not in the middle. So based on that, we try to analyze the ability of MCDA method, and based on that, of course, we build the knowledge base. We start from identifying the abilities of particular MCDA methods. If you are interested in finding this in our papers, I will try to explain you the block A. The papers are focused on identifying the abilities of particular MCDA methods. The characteristic of the methods can be easily explained by 5 classifiers: possibility of comparing alternatives, applying weights, definition of quantitative or qualitative importance of criteria, and possibility of comparing of all of alternatives. Based on that, I will not go explain this ability because I hope you know what is what. As we know, the classifiers are binary. The two possible values are possible: 0 and abilities do not exist. 1 when exists for particular MCDA methods, and based on the abilities and after analysis of set of main MCDA methods, not extension, lattice extension like resistance fuzzy set and spherical fuzzy sets, the main principles of particular MCDA methods, we build the rules for selection of MCDA methods. We see the 7 rules, but we can also easily see the main disadvantage of this approach is the size of the family of method fulfilling the requirement of particular decision situation for rules 6 and 7, for example. Here for rules 1, we have to use 3 methods to objectify our results of decision support process. The same situation, the rules are presented as decision tree. That's easy to understand. If you are interested, of course, you can check our papers. Next step, of course, we try to find the confirmation before the step. We analyze some literature reference examples, and based on analysis, we check the abilities, we check the reference methods used by author of the publication, and we use our rule-based system, and this way we try to confirm or not our approach. The exemplary confirmation is presented here. For wider discussion, see the literature. Of course, that's easy to observe that five easiest classifier do not reflect decision-making situation proper and can be easily extended by additional classifiers. For example, covering the different properties of MCDA methods like relative criteria performance of alternatives, possibility of using the fuzzy performance values of alternatives, classifier 8 take into account the particular ability of European-based MCDA method like threshold. And the last classifier, the performance of alternative on scale, full comparability of alternatives is checked. That way, we code one more time our MCDA methods family and divide it into the subset. And you can easily see that right now it's quite useful and depend on characteristic of decision-making situation, we can find the methods fulfilling that characteristic. And to proper solving the problem, we have the subset of MCDA methods which should be used to proper solve the problem. In easy word, it's can be said that it's done. Of course, that should be confirmed. Decision tree right now looks more sophisticated, let's say, and of course the same way of confirmation was done by our research team. We analyzed the reference literature, and here we have the methods used by authors and results of application of our rules give us subset, and we analyze 70 cases covering sustainable management, and when you see the confusion matrix, TPR is much higher than in the case of context-based approach. Of course, some examples are not in accordance with our guidelines. It depends. It can be easily seen in the example such easy method like AHP, where the author do not, for example, use the relative-based scale, where AHP works on a relative scale in alternatives and ways of obtaining process. But generally, it was high level of confirmation for that approach. And what we try to do more in the, let's say, scientific terms, we try to extend this research extend this approach in the case when we do not have a full knowledge about all aspects of decision-making situation. We know that the popularity and the focus of our latest research covers the area of partial lack of knowledge, and when decision makers do not have a full knowledge. So we try to do the same but we do it in a few steps. We build our set of classifiers, building new set of abilities. We generate the rule base. We model the uncertainty in the process of characteristic of decision-making obtaining, and based on that, we build the complete MCDA method selection algorithm and online expert system. Our framework consists of 4 main classifiers, which are quite more or less equal with the 9 classifiers presented here. This time we try to build the hierarchy of classifier, and we try to extend the values from binary 0 and 1 value to 3 or 4 value of particular classifier. You can see the weights, you can see the scale, decision problem and uncertainty, yes or not. What kind of problem? It's a basic classifying given in the reference literature like Roy or Slovinsky, where we have some basic problematic classification, selection, ranking, and so on. Of course, some of these classifiers can be clarified and fully defined, some of them not. For example, first classifier, third classifier, and fourth classifier can be modeled more accurately. That's why we decide, for example, if decision maker answer us that we have to use the weights, we have to ask the question, what kind of weight you are using? If we have uncertainty, you know that uncertainty can be characterized by decision maker preferences, values of attributes, or both of them. And the same way, if we ask the question about variance ranking, the question is, should it fully quantitative or only qualitative? Yeah, for example, graphically presented. Based on that, of course we have also uncertainty modeled for data criteria, variance, buff, threshold, what kind of threshold? Of course, if someone wants, it can be the extended indifference preference, or the weak preference can be also joined here. And based on that, we build the new rules for rules. First step, it was to build the taxonomy, in our opinion, of complete set covering 56 MCDA methods. We code particular properties for particular MCDA methods and their hybrids. And based on that, we present the formal side of every classifier. And finally, we build the decision tree, how to select MCDA methods. But we have to keep in mind that when we took into account so many methods, 56 particular methods, of course, the results of the classifying are subset of MCDA methods. Confirmation of our framework. Confirmation of our framework was realized the same way like in other research. We try to carefully analyze over 30 reference literature. The example from sustainable supplier selection, sustainability domain was carefully analyzed one by one, and based on that, we we built, we obtained the results over 90% TPR. But our rule-based was the enters for complete uncertainty modeling and handling in decision problem description. Here you can see which I carefully analyze whole possible domain of attributes, and we check the impact of missing data, for example, the number of classifiers in the results of final set. As you see, the final set, for example, is joined here. When we don't have information what type of uncertainty we have to join these two subsets as a one. It's a result of lacking of particular knowledge. Yeah. If we don't have any information about uncertainty, we should have all these subsets joined with that subset. Yeah. That was the reason that the uncertainty handling decision problem description problem was analyzed. The final result is a responsible, fully available the expert system supporting MCDA method selection. If you are interested in that speech, you can find the useful info, the whole working system on MCDA IT domain. That's practical technical system which can be used by us scientists, or however by decision maker also, and the literature where the sustainable based problems were analyzed is also given on this website. If you are interested, I can briefly present it to you, as we don't have a lot of time. So wait a while. MCDA IT, as I said, we have mapped our approach. As I said, if you are interested, you can find in our journals full description. They are open access buffed, so you have full explanation of sustainable MCDA-based decision making and problem and method selection. That's alliteration. MCDA IT, as I said. Here we have the practical side of our decision support system. You have the starting set of MCDA methods. The first question, if we have weights. If we have weights, yes. Uncertainty modeling in decision problem description allow us to reduce that entering set of MCDA methods if, for example, only one attribute is given or two of them relative, AHP based, and it works. Yeah, of course, if you have a full knowledge, you can detailedly model the situation. If you are interested, of course, you can find whole literature here. So, long story short, for 1 hour, that's all from my side, and thank you for your attention. Feel free to ask me the question. Thank you, ladies and gentlemen. Thank you so much. If you want to ask a question, you can do it via chat. You can do it personally. I'm for you. We have 5 minutes. I'll try to leave 5 minutes for discussion, hopefully, and Thank you so much. That was an honor and pleasure for me to give you some presentation about our research direction. Hopefully you will find it interesting, and hopefully you will find the interesting practical domain for your formal research. As I said, many recent developments of MCDA method as this, some newer development. So sustainability is very, very useful domain for practical basis for your research. Thank you so much, and I'm waiting for your questions.
Participants can ask your questions.
Yes, sure. Yes, sure.
Thank you, Professor, for one amazing presentation. You have explained the multiple criteria decisions analysis in detail and clearly showed us the emerging aspect of MCDA methods. Thank you once again.
Thank you so much. As I said, that was a great honor and pleasure for me. And due to technology, I'm with you. It doesn't matter that I'm 1,000 kilometers from India, but I visited India 2 years ago, Bengaluru, on the IEEE based conference. So thank you so much, and hopefully see you in reality. And if you want to have some questions, feel free to ask me. Ask it via chat or via email. Thank you so much for your kind words. Thank you.
Thank you, Professor. Participants can fill in the feedback link. It is posted in the chat box. Participants can fill the feedback link. It is posted in the chat box. And the paper presentation sessions are arranged parallelly, and we request the participants to join in the respective meeting links and proceed with your presentations. That's all for today. We request all of you to join the technical session tomorrow sharply at 9:50 a.m. Stay safe and take care. Thank you. I repeat, the paper presentation sessions are arranged parallelly, and we request the participants to join in their respective meeting links and proceed with your presentations. That's all for today. We request all of you to join the technical session tomorrow sharply at 9:50 a.m. Stay safe and take care.